Okay, I'm going to attempt this question of heat neutralisation, which is one of the experiments of organic chemistry, fuels and heats of reaction. It's on page 385, it's question 12. It says, a student mixed 250 centimetres cubed of 0.5 molar HCl with equal volume of 0.5 molar NaOH. Okay, in this experiment, you're expected to take the volumes of the solutions as the mass. So far I have 250 centimetres cubed of acid and 250 centimetres cubed of base. The combined volume then is 500 centimetres cubed. In these questions, you're always expected to take the the density of the solution that you're dealing with as being the same as the density of water, which is 1 gram per centimetres cubed. Therefore, instead of saying I have 500 centimetres cubed of solution, I'm going to say I have 500 grams. We'll read on. It says, the original temperature of both solutions was 14.8 degrees Celsius. Usually we work in Kelvin, but because the unit of Kelvin to degrees Celsius moves up periodically by the same amount, it's okay to just leave these in degrees Celsius. It says there the temperature then rose to 18.2 degrees Celsius. The fact the temperature went up means it's an exothermic reaction. So at the end of this calculation, we'll expect our delta H to be a negative value. So there's just a small thing to remember to put in at the end. And then it says, calculate the heat of neutralisation of hydrochloric acid and sodium hydroxide. Assume that the density of the final solution is 1 gram per centimetres cubed, which we've already done. And we're given a value for C, which is the specific heat capacity of the solution. That's always given to you in the question. For this one, it is 4060 joules per kg per Kelvin. So that's always going to be given to you in the question. So the overall heat change is going to be the mass multiplied by the specific heat capacity multiplied by the change of temperature. The mass here has to be in kgs. Specific heat capacity is given to you in kg anyway, so that's fine. And the temperature here is going to be the difference between T2 minus T1. So the mass that I have here is now 500 grams. I need to convert that into kgs. So 1 kg has 1000 grams. 500 grams is literally half that amount, so I can say 0.5 kgs. So the mass I'm going to include in my equation is 0.5. The specific heat capacity given to me in the question is 4060, and the change of temperature is the difference between my temperature before and my temperature after. 18.2 minus 14.8, which gives me a temperature change of 3.4 degrees Celsius. So 3.4 degrees Celsius goes in there. Now you simply just pop all that into a calculator. So 0.5 by 4060 by 3.4 gives me an overall heat of reaction of 0.2 joules, and joules is the unit for energy, so I'm going to stick in joules there. Now, when you're calculating heat of neutralisation, the definition states that it is the overall heat change when 1 mole of hydrogen ions from an acid react with 1 mole of hydroxyl ions from a base. So far in this question, I actually cannot be certain that what I'm dealing with is 1 mole of hydrogen ions. So what I need to work out is how many moles of HCl do I have here. Now, how do you calculate moles? It's volume by molarity divided by 1000. The volume of acid that I had here from the question is 250 centimetres cubed. Remember, when you're using this calculation to find moles, the volume must always be in centimetres cubed. The molarity is given to me in the question as being 0.5 molar, and you divide that by 1000. So again, in a calculator, that gives me a molarity of 0.125 moles of HCl. So I'm far away from the 1 mole, which is what I need to find heat of neutralisation as per the definition. So again, this value of heat of reaction or amount of heat given off is only applicable to 0.125 moles of HCl. So I can say when I react 0.125 moles of HCl, 6,902 joules of heat energy is released. I am not concerned about 0.125 moles of HCl, I'm concerned about 1 mole of HCl reacting, because that is what will give me a heat of neutralization value as per the definition. So 1 divided by 0.125 will give me this kind of, what would you say? Will give me how many times this is smaller than 1 mole, which is 8 times smaller, which means that I need to multiply that value by 8 to get 1. Likewise, I'm going to multiply this value by 8 and I get 55,216. Again, this is joules. So if I had 0.125 moles of hydrochloric acid undergoing a heat of neutralization reaction, it would release 6,902 joules of heat energy. In order to satisfy the actual heat of neutralization calculation, I need 1 mole of hydrochloric acid reacting, or 1 mole of H+ ions reacting. So hydrochloric acid, when undergoing neutralization, will dissociate to give you H+ ions and Cl-. So 1 mole of HCl will actually give me 55,216 joules of heat energy. The final thing we need to remember is this reaction saw an increase in temperature by 3.4 degrees, meaning it's an exothermic reaction. So you simply go down to that value and put in a minus. So we're telling our examiner that this is the amount of heat energy released when 1 mole of hydrochloric acid is neutralized.